What I'm about to show you is going to create a revolution in almost every type of humankind's presence in space. If you're one of the millions of people who want to visit space in the next few years, you should watch this video. In the 50s and in the early 60s, NASA wanted to create large rotating space stations as a way of having a permanent presence off-world. They knew the best design was the torus, and they knew if they could build it, humankind could expand into our solar system quickly. But we went to the moon instead, and after that the budget got cut, and so did their big station dreams. Once the space station designs became smaller, so did our hopes and dreams and aspirations, and over time our confidence to do big things. SpaceX Starship opens the door to do big things again. With this new big rocket will come the new big space construction machines to create the voluminous structures that we wanted long ago. In 2012, I started Gateway, and in 2014, I designed and patented the first large-scale space construction machine that could build large structures using an assembly line method. This machine is called the G-cell, but the most efficient design ever created for space habitation is the torus. The G-cell cannot create a torus very well. It's not designed for that. However, it is very good at building truss in many different shapes and can reconfigure itself very quickly. Since that time, I have designed and engineered, funded and fabricated other machines that build truss. They do it fast and with precision. I have also designed a series of drones that assist in space construction in many important ways. Now I have designed 4 new space construction machine product lines. Number 1, a torus builder. Number 2, a large-scale station interior builder. Number 3, an off-world spacecraft builder, and number 4, a large module builder. All of these new machines are based around a new type of space construction technology, panel construction. Meet Sargon. It is a torus builder using a panel construction ring. This machine does not build truss. This machine is a station builder, a spaceport builder. This machine fabricates very large pressurized volumes very quickly. And yes, it can also build a torus-type station, like this one. This is VERA Station. VERA stands for Voluminous Environment, Rotating Architecture. VERA Station is not a space station broken up into modules like the International Space Station or other space station designs. It is a torus, a continuous volume. No structural breaks or divisions all the way around. This is why Sargon is the first of a new class of space construction machines that are called continuous volume generators, CVGs. A torus is the perfect shape for a rotating space station. That's why we see it in so many sci-fi movies and shows. The National Space Society lists a torus as the best candidate for a space station design. VERA Station's design offers enormous interior volume for its mass. The torus you see has a huge volume of 85,278 cubic meters. That's 91 times the volume of the International Space Station. But this is just the torus surrounding the hub. It has a diameter of only 84 meters. The outer torus, where guests will stay and play, is much bigger. The diameter of the outer torus is 224 meters. Together, both of these tori offer 370,000 cubic meters of habitable volume. That's enormous. VERA Station is a Two Torus design, connected by 4 elevator shafts and a spoke structure. At the center is a circular hub designed to accommodate SpaceX Starships and a new class of spacecraft called the Station Transfer Vehicle, or STV. The hub is divided into 2 ports that can operate independent of each other. Only the acceleration tubes at the center of the hub despin to facilitate docking while the station is in rotation. The outer torus offers an enormous habitable volume, so why have 2 tori? The inner torus can be built in a much shorter time than the outer torus, and once completed, offers the construction crews a very large facility to work from. It will also offer our guests and crew a refuge should the outer torus need to be evacuated. Emergency and evacuation systems of VERA Station will be covered in our next video. For almost a decade, I have been designing space construction machines, spaceports, and drones to help form a space construction industry. Now the future of space construction looks even brighter with the Sargon construction ring, the first continuous volume generator, a machine able to build very large pressurized volumes very fast. I think this is the breakthrough that humankind needs to become an off-world race. Of all of the machines that I have designed, engineered, and fabricated, those machines do not make pressurized volumes. Mostly they build truss, an important component of large structures in space. Making a better truss building machine is evolutionary, but Sargon is not an evolved truss builder. This machine is revolutionary. It represents a quantum leap in the field of space construction. The implications of its development are stunning. This machine, Sargon, is different. This machine does not just build truss, it builds stations. In order to rotate the stations built by Sargon, truss will be needed. That's okay. I have designed and built those machines before. But this machine and its derivatives can build the pressurized torus, the interior floors, the elevator shafts, and the exterior solar panels all at the same time. When I was speaking at the Space Settlement Enterprise in Seattle in 2019, a young woman asked our panel if a machine were capable of building large enclosed pressurized volumes. This machine is the proper answer to her question. 3 years later on, I can say without hesitation, yes we can, and we will. But it can build more than just a torus. The construction ring will also build some very large spacecraft. To build big spaceships on orbit, like the STVs, is another business opportunity that we will capitalize on early in the development of Sargon technologies. Why a torus? For decades, we have been designing and building module-type stations. They have evolved to a point where we expect to see more and more of them in different configurations. But all module station designs have a limiting factor that is wasteful by the nature of their design. Module stations are an architecture of segmented volumes. This requires a lot of material to be used in creating heavy hatches, tubes that join them, and couplings. The impression of life in a module station is confined, and much like that of being in a submarine. A large torus station design like VERA is a voluminous and continuous station architecture that gives an unconfined feeling, more like what we have here on Earth. In only a few years, people will have a choice of the kind of station they visit in low Earth orbit. The construction ring's ability to create a continuous volume of almost unlimited size makes the choice easy. In the future, we believe that modules will only be used as zero-G laboratories and small stations at the edge of humankind's reach into our solar system. A torus can be formed with a collection of panels of different size and shape. A torus built in this manner is made of rings and rows of panels. Panels in a row are all the same size and shape. Panels in a ring are made of 2 identical ring halves. Each half will have 16 different sized panels that form a 32-panel ring. These are known as panel rings. Sargon will move these panels into place to form each panel ring that makes up the torus. The process of building a torus in this manner is called Rapid Sequential Circular Assembly, or as we say, RASCA. This is how the construction ring will build VERA Station. The inner torus is made up of 84 panel rings. The outer torus is made up of 192 panel rings. If the construction ring can assemble 1 panel ring per day, then the inner torus could be built in less than 3 months. The outer torus would take about 7 months to construct at this pace. The hub and other truss structures will be built concurrently using the G-cell renamed VISTAL for VERA Station Truss Assembly Line for this project. Total project construction time, less than a year. Building a station this large, this fast is remarkable. It took us 20 years to build the International Space Station. But could VERA Station be built faster? When we build a panel ring, we place the first panel into the number 1 position, and then after secured, we place the second panel in the number 2 position in a counterclockwise sequence. But what if, as we place the second panel here, we could simultaneously begin positioning panels in a clockwise direction on the other side of the number 1 panel? RASCA is sequential, but it can work in both directions at once. This is called bidirectional assembly. This would mean cutting the build time for VERA Station in half. Instead of 3 months for the inner torus, we're looking at 6 weeks, and only 14 weeks for the big outer torus. Using this method, we could build this massive station in only 6 months. But the construction ring is not designed to build 1 or 2 panel rings per day. It's designed to build 1 panel ring every hour. If we are building 1 panel ring every hour, that's only 84 hours, 4 days to build the inner torus and 8 days for the outer torus. And that's if you're using only 1 Sargon construction ring. Imagine if you had 2 construction rings building in opposite directions. Now you could cut that time in half again. The hardest part now is to feed the beast. The construction ring could build panel rings very fast. Can we supply the panels to the construction site in time? Or does Sargon sit idle for days waiting on the next delivery of batteries and panels? I am convinced that we can deliver in time with a small group of dedicated starships. Over time, the construction team will develop a cadence that matches the available launch assets' capabilities. But I don't think SpaceX is going to hold us back. They have designed and developed a lot of launch assets that can reload and relaunch a Starship very quickly. Starship is the answer to everyone's dreams when it comes to building large structures in space. This amazing rocket will lift 150 metric tons into orbit very affordably. Its projected turnaround time is only hours. That is extraordinary. But a newer designed Starship may lift 200 metric tons and offer a bigger cargo volume. For the new space construction industry, this is the answer to our dreams. The panels are composed of 5 cm thick 2219-T8 aluminum alloy whole metal with Whipple shield on top. There may be other integrated features such as polypropylene layers added to its interior for radiation protection or a water jacket. Each of the panels are curved or flat as depicted here. This flat panel depiction is an option. Panels for a torus are not square, they are trapezoidal in shape. There are 16 panels per half panel ring, and each one is unique. The panels will be made here on Earth and launched in a stacked bundle 10 panels deep. Then they will be loaded into the magazines that feed the construction ring. The region where the panels are mated together is called the panel interface zone. Panels are joined using electron beam welders assigned to each row. Sargon builds panel rings by welding together the seams of aluminum alloy hull plate quickly. We are depicting a Kimball Physics 4210 electron beam welder in this illustration, but most likely a custom weld head would be built for our needs that has more power and is designed for the challenging environment you would expect of a sun-synchronous construction site. Each panel has numerous attachment points on both sides of its surface for pods to attach to for repairs or maintenance. Window panels are the same size as regular panels, and this feature will allow us to create different window configurations to suit a client or hotel operator's needs. This accelerated speed of construction would most likely come after VERA Station was complete, as we are sure to learn a lot from building the first one. But when we get good at this, and we will, then we can start building more stations like VERA every 30 days. I am currently working on a floor building machine that follows the construction ring inside the torus and lays out floor sections with electrical and plumbing pre-installed. I believe that stations like VERA can be built in 2 weeks, but the real gem of off-world vacation spots will be much bigger. Those of you who know me, like the Gateway crew, know of my plan to build a massive Gateway Spaceport. The construction ring is the machine that will do that, but far faster than I had thought possible only a year ago. In 2015, I created this video depicting the assembly of the Gateway Hub and the LGA in 721 days, and over 1,000 days for the big MGA, the outer ring. Back then, it was considered a very ambitious timeline. Now, I believe we could build the entire Gateway Spaceport in a month. How? By having multiple Sargon systems operating at once, by having these construction ring batteries charged not on Earth, but in space at solar farms, by having panels fabricated on orbit and only panel feedstock lifted to orbit for fabrication, instead of bulky finished products made here on Earth lifted in bundles, as we'll have to do when building the first VERA-class stations. Stations built on orbit with station components fabricated on orbit is far more efficient. This is all part of the plan. We will build many VERA-class stations for tourists, but somewhere along the way, we will create a special station called Vespertine. Vespertine Station will not be for tourists. This station will be where we create station components, panels, floor panels, wall sections, and solar panels that will be used to build other stations. Also, testing of new safety systems, spacesuits, and construction equipment will also happen here. Vespertine Station will be also where station crew training will happen. Think of this as an off-world station crew academy, production and research facility. Vital to that orbital manufacturing role will be the big station transfer vehicles, or STVs, that move people, materials, and construction ring batteries into position for construction at other off-world locations. The STVs will also play a vital role in interstation commerce as clusters of stations are quickly built to form off-world communities. Crew training at Vespertine Station will instruct construction crews how to build other stations. Their work includes assembling and testing construction machines like Sargon and EVA training ops for both building stations and building space vehicles like the big STV. They will also train station operation crews to run other rotating stations as the orbital community grows. Vespertine Production will oversee the production of many station components for construction of other stations, but also newer components too large to produce on Earth and launch on rockets. One of the most exciting projects will be the fabrication of the massive Gateway Spaceport. This ultra-fast pace of space construction will forever change humankind's ascension into our solar system and to the stars. The benefit, however, will be personal, as many of us who thought we would never have the chance to visit space will have that chance, and not deplete our retirement accounts in doing so. Building lots of big stations fast will have that effect. Building VERA Station will forever change our culture. When the price to visit space becomes affordable, then people stop thinking about if I will visit space in my lifetime. They'll now think about when I will visit space. That cultural change is dynamic. Once it happens, its influence will grow into a dominant part of our lives wherever we are. People who visit space say they're forever changed. Just as a person who gets their wings when they become a pilot is never the same, so too will a person who becomes an astronaut become a citizen of an off-world culture. I believe they will see others who have shared this experience in a familiar way, a fraternal way. The building of new communities off-world will dominate the attention of people everywhere because everyone will want to go, and many of those who want to go will. Television programming will offer many shows based on people living, visiting, or working in space. It won't matter where you're from or what language you speak. People all over the world will be talking about visiting these off-world communities. Imagine what the reality shows will be like. Building communities of stations off-world and facilitating their growth will become a cultural vector. Besides its amazing speed of assembly, VERA Station's greatest feature is the extraordinary volume of its pressurized interior that we can offer to our guests. The station's capacity is not restricted to any rocket fairing size. Interior layouts are being developed for you to see. But for now, all I can show you is this 5-level interior floor plan of the station with the hull removed. If anyone with skills in creating interior station images would like to donate their time by helping us depict what being inside VERA Station would be like, please use the link provided here. Everything is going to change with the introduction of a machine that can build a big rotating space station in less than a month. But the plan is not to build one or two. The plan is to build many of them. The construction ring will bring to space a word that we often seek: durable. This machine is designed with high reliability in mind from the start. Each construction ring is engineered to build not a few, but hundreds of stations. This machine is an empire builder. That's why we call it Sargon. Creating clusters of stations that complement each other's capabilities is imperative to this plan. If there's a problem on the station's main torus, they go to the inner torus. If for some reason both tori need to be evacuated, then people don't go down to Earth. They board an STV and go to another VERA station nearby. Once perfected, the speed and versatility of the construction ring will create a belt of stations that will bring down the price of orbital space habitation to a level not thought possible for decades. All of my life, I have wanted to visit space. In the last 10 years, that ambition has grown towards building spaceports and forming a space construction industry. I believe those of you watching this show feel the same way. The construction ring is the enabler of that dream and the chance of a lifetime for all of us who want to go up. Just VERA Station alone can handle 100,000 space tourists a year. It is possible we can have many VERA-class space stations operating before this decade ends. I believe this amazing machine will create the station or spaceport that we will all be able to afford to visit in our lifetime. We're going to be able to do this fast because we're going to get good at this, and we're going to get good at this because we're going to do it a lot. Instead of sending up the right stuff, we will be sending up everyone who dreams of going to space, and that is the right move. This machine will start a seismic shift in humankind's expansion into our solar system. This new space construction machine will become the centerpiece of a new space construction company, Offworld Industries. This corporation will be a vertically integrated corporation. That means it will make big space stations, very large spacecraft, and even the habitation modules where the construction crew will live. But Offworld Industries will also make the tools for large-scale space construction, like Sargon. Before the end of this decade, we wish to achieve the following goals: to build at least 3 VERA-class stations in low Earth orbit, to create a space construction industry where many elements of that industry are operating off-world, to create at least 1 Vespertine-class station, to have over 300,000 people visit space, and to start construction of the Gateway Spaceport. If we can meet these goals by 2030, then we could have 50 Gateway-class spaceports off-world by 2050. That is what you can expect from a broad, well-established space construction industry using continuous volume generator machines like Sargon. VERA Station will become everyone's favorite station because it'll be the station they can afford to visit. Having dozens of high-volume stations built quickly means the price to visit space will come down quickly. It's no longer about seeing your favorite TV stars or athletes in space, it's about us, our chance to go. I believe people have to have their own experience off-world, not watching videos of other people having fun or knowing someone else who went up. That means it has to become affordable soon. This is just the beginning of something big and amazing, and this time, you're going to be a part of it. Imagine a space construction industry building huge spacecraft and stations in months, not years. I believe this machine will be improved upon beyond what I can foresee at this time. It'll become faster and able to build larger ranges of shapes and structures that I can barely perceive right now. With this technology, the space industry could start developing products as fast as Silicon Valley does. VERA Station and the machines that will build it is why all of the videos I've made before have been taken down. I believe this new way of creating large stations, large modules and spaceports will become the dominant method of space construction. Some videos will be remade with our new name and logo, but all the timelines of construction and development that were estimated in years are now estimated in months. This new technology changes everything. This first video of the Sargon construction ring and VERA Station is just an introduction. In our next video, we will show you how VERA Station's emergency and evacuation systems will make the station more affordable and safer than all other existing stations and station designs. We will be looking for seed investors soon. If you are interested in becoming a part of the investment team for Offworld Industries, please tap the link above. Mr. Bezos, this is your dream. We should meet and discuss this technology. Mr. Musk, this space station can only be built with your rockets, and those big batteries, they could be made by Tesla. Let's get together and talk about that. In only a few years, we're going to need lots of people. If you want to support our effort to form a space construction industry and build spaceports like the Gateway, then please join our crew membership at gatewayspaceport.com or tap the link here. What a time to be alive, and thank you for watching.